Hello! The purpose of this video is to help programmers identify coding inefficiencies often found in code, especially concerning beginning programmers. So let's get right into it and take a look at some of the common coding inefficiencies. So one of the ones that I see quite often is poor or repetitive logic. So here's an example of a program that's going to count to 1 million. And a typical beginning programmer might write a loop like this, which is fine, but we probably should take the well-known mathematical shortcut of, this is Gauss's formula here, the number times 1 over the number divided by 2 will give you the total. And this would be a considerable shortcut over using this loop here. So that's the first example. The second one that we're going to be talking about is using good variables versus bad variables, and also good function names versus bad function names. So here's an example of a program that uses very poor variable names. For example, S is assigned to the buffer for the open sales text file, and another bad variable is using these you can't even tell, but that's a lowercase l, and so that's a bad choice because that's going to cause confusion. And you can see that they just used any short letter. So this is a better example here. So you can see that in this program here, we know what's going to be in that variable. It's going to be the data from the sales text. Okay, and I'm also going to see that we use I here instead of L. And we're going to use number instead of A, and so on down through here. And you can see when the sales file is closed. So this program is a lot more readable than the one with the very poor variable names. And same thing about functions. Okay, functions and variables pretty much follow the same naming convention. So the third idea that I want to get across are how important comments are. So here's a program that is going to find and this is just pseudocode, but here's a program that's going to find the position of the mouse cursor at any given time on the screen, and we're going to set the x coordinate for the mouse to x and the y coordinate to y. But you can't really tell that if you don't really happen to have those numbers memorized right there. You can't really tell what this program is doing, but you can see in the example here when we have the comments, you can see that it's explaining a whole lot better what's going on in the program. Especially if you're working on a program, you might have those numbers on the top of your head when you're working in a program, but if you put it away for a year or two and you come back and what were those numbers? So it really helps to have these comments there. So it really explains what's going on in the program. So even if you're not a programmer, and even though this is pseudocode, you can see what's going on in this program just because the comments are there. Okay. So let's go to the next one here. Talk about loops versus repetitive code. So in this situation, we're going to count to an unspecified number, but the user is going to put this in here. But so if you're going to print a few lines, you could do this manually. 10's not too bad. I could copy and paste that in there. But the problem is when a loop has to run to a large number. Let's say we're going to run to 100,000 or something like that. Then that's not going to be very good coding here to copy 100,000 lines of code down through there. And of course, the chance for a human to skip a number or have some other type of error is very high when you start doing those types of numbers through copy and paste. So a loop for this type of work would be a much better choice than repetitive lines of code. Okay. Let's go to the next topic now, and we're going to talk some about versioning. So what is versioning and why is it used? So if you worked in an online class and you've worked on some paper or something for quite a few days, and now you can't remember which version of the paper is the one you want to submit. And so this is basically organizing your document saves and your program saves into a fashion where you can track what's the latest version. I do that a lot by using the data of the file, but at any rate, typically the way versioning works is that you just go ahead and put this kind of numbering system, say, on the end of your file. So this is version 3.10, and if you were switching to version 4.10, being the fact that this number is to the left of the decimal and it's changing by 1 is considered a significant version change in a program. Whereas a version change from, say, 410 to 420, and this is a change on the right-hand side of the decimal, is considered a minor version change in a program. So, for example, Python 2.7, is way different than Python 3.7 because there's a major version difference between 2.7 and 3.7. But, if you got Python 3.8 and you switch to Python 3.9, you're not going to notice, that much of a difference unless you're doing something, really picky or something. So that's always good to keep in mind. And here's some basic ideas about versioning and why it's used. Okay. Versioning actually was developed by programmers, and other authors and writers decided it was such a good idea they decided to use it. At least that's the history that I've read on the internet about it. Okay, let's see what the next topic is. We're going to be talking some about hard coding and why it's bad. So exactly what is hard? Here's an example of hard coding. Now I've set n equal to 100 here, and then I'm going to print, 1 to 99. And then I'm going to do it this way, where n is allowed to be entered by the user. Well, you see, in this program, if it needs to go 100,000 or a million, I've got to go edit code to do that. And if you're doing, something in C++ or something, and you're going to compile it in exe, you got to go back to the source code and do all this stuff. And it's better to have variables like that, put in by the user at the time of run. So, I got some explanation about that right down here and what's going on. But you might say, well, then is count also hard coding? And the answer to that is count is not hard coded really, because count is expected to always start at 0 when you're doing a count. So we know computers start at 0, and so we're going to count these, we're going to count starting with 0. And that's the idea, that count's going to be 0 whenever you're running to a particular count like that, is going to be that it always starts at 0. So it's more like a constant and then a variable. So anyway, so when you see a number like this, and the purpose of this loop is to count, and n is the sentinel variable that's controlling things here, then we want to be sure that we don't put it in like this. We even see some examples in our textbook where this is done, and it's for teaching purposes, but this is not really great code right here. It's much better to get that variable n assigned by using an input statement or some similar coding. All right. And by the way, that's a bad example. That's an example of a bad variable usage, right? There should be something like number or something. But when we're teaching, we kind of break a few rules just because we want to stay focused on what the topic is right there. Okay. All right, and let's go on here. We'll talk a little bit more here about one more thing. There's one more left here. And then we're going to talk about global constants versus global variables. So a constant, and when it's needed in more than one function, it can be declared as a global constant. So global constants are okay because, again, just like the last example, the constant's not going to change. So the value for pi, 3.14159, whatever it is, that's not going to change. So it would be okay to set up pi as a global constant. But global variables are a no-no. We won't want to do that. Although you can do it, it's not a good idea. It usually indicates that there's some bad logic or some bad programming design going on. And you should not use them in books, and myself and other teachers and programmers frown on global constants. And especially when you're working in large groups of people, we don't want to have global variables. We do not want to have global variables outside of main in a program, because that's one variable nobody can use because it's out there globally. And we want to keep those variables local. Now constants, it's okay. So it's okay to use a global constant, but it's not okay to use a global variable. And again, a global variable would be a variable that's declared way at the beginning, after some of the directives and all, way early in a program, before main and all that, so that the variable is available to all functions. And that's kind of bad programming. You should be able to think that through and figure out a better way to do it. So we don't want those global variables out there declared before or outside of main. They should be declared in main, which the scope would be in main, or the variable would be in the scope of the function that where it was defined. Okay, so that's the reason we do that, is because if you make them global, then that's variable names that programmers have to watch out for and not use in their functions. So we don't want to do that. I hope that's clear. And that's just an overview of some of the things that we see in early programmers that is not really good coding. We call it inefficiencies in coding, or coding inefficiencies. Okay, hope you've enjoyed the video. Happy programming, and I'll see you next time.